Hello, my name is Antoine Gagnard and I work on LoRaWAN topics at Savoie-Mont-Blanc University. In this video, we are going to use the LoRaWAN data fragmentation to send a large data file to an end device. Let's see how it works. Well, to perform a fragmentation session, we must follow a process. As you may have guessed, we need a file to send. To get it, we will use a Python tool we have created. It generates an arbitrary data file and it fragments it. Then we will send these fragments to our end device. Thanks to them, it will autonomously rebuild the initial data file. This end device is a STM32WL55. It is activated and works in class C. To carry out this process, we need other equipment. There is a Nucleo F74 6AG as gateway. We will use Firmware community from Actility as network server. Lastly, we will send our fragments and manage the fragmentation session through a dashboard we have built at USMB. And before starting, let's have a look at this dashboard. On the left and on the top are sections. They describe the main fragmentation commands. Actually, several other commands exist, but we will only focus on the most useful of them for the demonstration. This Node-RED dashboard is connected to Actility network server. That means it allows us to send downlinks and receive uplinks. At the bottom, there is a downlink area and an uplink analyzer. It will help us to understand payloads received from the end device. Right, we can now start the demonstration. First, let's create the file and the fragments. I launch the Python script. First, it asks which mod to use, and I choose interop. With this mod, the script generates an arbitrary file. Then I shall set the size of the fragment. Let's say 4 bytes. Then again, I set the number of desired fragments. I want 5 of these. Well, I can now see my generated file. It also gives me the fragments. The uncoded fragments correspond to a simple division of the initial file into 5 parts. Below, there are coded fragments. It relates to the redundancy. These fragments are used by the end device to reconstruct the data file even if it missed one or more uncoded fragments. Finally, I save my fragments as CSV and SFB file. Let's begin the fragmentation session. The very first step is the session setup. To do so, I will use the frag session setup frag command. First, I set the session ID. An end device can handle 4 different fragmentation sessions at the same time. This ID is used to identify the one we are gonna set up. Let's say ID number 0. The multicast group bit mask is used to identify to which multicast group we will send the fragments. In our demonstration, we don't use multicast, so I set the default value, that is 40. Then I set the number of uncoded fragments. It is 5. I also set the size of the fragments to be sent. It is 4 bytes. I precise the algorithm to be used by the end device to rebuild the file. The only one that is implemented is the FEC algorithm. Its value is 0. Hack delay is a useful parameter in multicast context. It avoids uplinks collision when end devices try to acknowledge a fragmentation command. In our demonstration, we don't need it. I set it to 0. All fragments generated are all the same size. We don't need padding either. And finally, I set an arbitrary descriptor. All fields are completed. I can create the command. Now, to send it, I copy-paste the payload in the downlink area. I precise the port, which is port 201 for fragmentation commands. And lastly, I set the dev UI of my end device. Then I send the downlink. On the uplink analyzer, we see the end device has acknowledged the command. From now, the end device is ready to receive our fragments. To send a fragment, we must use the data fragment command. But that means we must send each fragment by hand. That is not effective, especially when there are hundreds of fragments to send. That is why we will use the Data Fragment Auto tool. It sends the fragments automatically. First, I upload my fragments file my Python tool has generated. I can see here that the uploaded information is correct. 5 uncoded and 5 coded fragments of 4 bytes. Well, I set the dev UI of my end device and I fill the fragmentation session ID, which is 0. Then I set up the session. Great, session is ready to go. In tandem, I open a HTML window to see my end device logs. And I start the session. Excellent. We see the fragments arrive on the end device logs. When the end device has received the 5 uncoded fragments, it can rebuild the data block. But the fragmentation server doesn't know that, and it will continue to send the redundancy fragments. To deal with that, a user uplink is sent to signal that the fragmentation server can stop sending data. Well, the end of session uplink frame has been received, and on the end device logs, we see that it has rebuilt the data block. So, everything went well, we managed a successful fragmentation session. Fragmented data block transport can be an essential feature for several applications, mainly in a FUOTA campaign. To learn more about data fragmentation, feel free to check our ebook, which will explain all you need to know about this feature. If you want to make your own fragmentation session, the Node-RED dashboard and the STM32 project used during this demonstration are also available. All needed information and links are in the description below. I hope this video helps you. Thanks for watching.